So hello and welcome to part 2 of 2 for Intro to Kubernetes. Whereas part 1 we focused on setting up Kubernetes, part 2 we will focus on using Kubernetes, which is arguably more useful for most folks. As usual, quick disclaimer, I am not an expert. This is using the knowledge that I have acquired through my professional endeavors. And I will basically do my best to share with you what I know and what has worked for me. Additional disclaimer for this event, I set things up on AWS EKS, and the things specific to AWS I am not teaching because this is a general Kubernetes class. If you're interested in AWS, or if you are interested in Kubernetes specifically on AWS, just mention it to me afterwards and we can look into setting up an event. Or if you're interested in Kubernetes on a different cloud, like GCP or Azure, just let me know and we can figure something out. Azure would have more lead time because I've barely even touched Azure, but GCP I could do on a whim. So cool. Today's agenda, we're going to go over what can we use Kubernetes to do, basically why are we doing this. We'll go over what are objects in Kubernetes, which is basically how you do stuff in Kubernetes, or what there is to do in Kubernetes. We'll go over kubectl, the command line utility for Kubernetes, and how to, again, do stuff with it. And then as kind of a bonus, we'll also briefly cover a CLI utility called Helm, which makes managing Kubernetes stuff significantly easier. Any other questions or any questions before we get started?
Nope.
Cool. All right, let us dive in. So real quick, the structure of this for the first portion of the class, we will be going over concepts, and in the second half of the class, we will be doing the actual stuff. So let's go. So this is a little bit of a repetition from part 1, but just again to be thorough, what can we use Kubernetes to do? To put it very simply, like unfairly simply, Kubernetes hosts applications. It's much more complicated than that, but if you had to explain to a non-tech person, you could just explain it like that. It hosts stuff. And it does this by deploying Docker containers, configuring load balancers. It does secret and storage management built in. If you were in class 1 or the part 1, you remember we talked about etcd. It uses that. And it also allows you to request and manage persistent storage for things like databases and whatnot, or Prometheus, as was mentioned last class. And all these tasks are managed by what Kubernetes calls objects. There are many, 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 many different kinds of objects in Kubernetes. We are not going to cover all of them, but we will cover the most important ones that you will definitely use. Questions about that so far?
No.
Cool. And so let's dive right into what are objects. As mentioned, objects are different things in Kubernetes. The most common ones are things like pods, services, config maps, secrets, replica sets. There are more, and we'll cover more than just these. But these are kind of the ones that you'll be working with on a day-to-day basis. And we'll explain these in detail. But before we go into the individual types of objects, we should probably cover stuff that's common to all of them. First off, in Kubernetes, all objects are defined by YAML. Technically, I believe you can define them in JSON as well, but everywhere you see Kubernetes stuff, they're going to be using YAML. If you're not familiar with YAML format, it's not that hard, especially if you know JSON already, you'll be able to pick it up pretty quick. And everything is managed by the Kubernetes API. When you use kubectl, which we'll get to later, it's really just a wrapper for the API. Also, all objects have some name and ID. You only need to provide a name. Kubernetes will generate the ID for you. All objects have labels and selectors, which is useful for when you want to do operations against multiple objects at once. And we'll get into how to do that. And there are also annotations. Now, many people get confused between labels and selectors and annotations. The easiest way to think about it, labels are for humans, annotations are for other machines like Kubernetes itself or other services that are basically Kubernetes add-ons, things like that. And we'll go over a couple of examples of annotations and labels so you can see the differences as well. Any questions about these common things among Kubernetes objects?
Not right now.
Oh,
Cool.
okay.
All right. Then let's move forward into the actual objects themselves. The first one we're going to cover is a little bit of kind of an exception object. In Kubernetes, the nodes are listed as objects. If you remember from part one, nodes are basically the physical hosts or virtual, whatever it may be, that belong to the cluster. So when a host joins the cluster, Kubernetes creates a node object to represent the host that has joined the cluster. And so they're only partially managed by YAML and the API because when it joins, it's created, whereas everything else you create through the API, or mostly everything else. And as I mentioned before, these are the underlying structure of Kubernetes. Usually you don't need to worry about nodes too much except when you're first setting up the cluster. Usually after that, you don't need to worry unless you're doing kind of specialized nodes. For example, let's say you're doing a Kubernetes network that does or Kubernetes cluster that runs machine learning jobs, then some of your nodes will need to use GPUs and some of your nodes won't, and you'll need to do stuff there using selectors, but we'll get into that later. And I actually need to set that up in my company, which is going to be fun. Next up is namespaces. Namespaces are, well, they're like namespaces in any other thing. They're just ways to group objects according to name. Now, not all objects exist inside namespaces. For example, nodes don't belong to a namespace, they belong to the whole cluster. But things like pods are in namespaces. And that's just something you'll kind of figure out and logic through over time. It's not something you need to worry about too much of memorizing which ones are and are not in namespaces. Basically, if you try to look at info for an object and it returns nothing, it's probably in a namespace. And we'll demonstrate this in the interactive portion. Kubernetes, after being set up, does create a default namespace, which is where everything gets created by default. You can change your default namespace for your session, and we'll touch on that a little bit. There's also an honorable mention. There's another namespace called kube system, which is created automatically, and that's where you should set up things that will affect the whole cluster and are kind of part of the Kubernetes system. And we'll take a look at those later too. Questions about nodes and namespaces?
How many like nodes can be controlled by a Kubernetes control panel?
Yes. um, I don't know the specific answer, but probably bigger than you want to worry about. But let's see if we can find real quick. Kubernetes max number of nodes. Oh, no more than 5,000 nodes. There you go. I did not know that actually, so thank you for asking. Does that answer your question?
Yeah.
Cool. Other questions?
No.
Cool. That was a good one. I know some cool trivia now. Moving forward. Pods. If you've heard anything about Kubernetes, you've probably heard someone mention pods. Pods more or less represent a Docker container. You can actually have multiple containers in a pod. It's generally recommended against, but it is possible, and there are cases where it is a good idea. But usually you should think one container, one pod. A pod defines things like what image the container will be from. You can do environment variables, configurations, including secrets. You can do persistent volume storage. You can do labels and selectors to do network routing and all that kind of stuff, which we'll go over in detail later. Basically, they're the kind of main part of Kubernetes. And basically, when you create a pod, you're telling Kubernetes to run some container or group of containers. It is worth noting that because Kubernetes is doing kind of cluster management, and you're going to have potentially many pods on a single node, you are able, and I strongly recommend should, set resource limits on a pod so that it doesn't basically kill off your other pods by accident. So you can set CPU and memory limits for a pod. Additionally, you can set node affinity for a pod, where you can encourage pods to be allocated to certain nodes or forbid them from being allocated to certain nodes. For example, I mentioned earlier, there might be a case where you have some worker nodes of your cluster are running GPUs for machine learning jobs. Within your pod definition, you could set a node affinity that the pod should be deployed to a node that has a GPU, or rather, more specifically, a node that has a label that you add saying like this is a GPU node, and then you can have that pod target that GPU node. And there's all sorts of documentation on that. This is we're doing more like showing you what is possible, and then you can always Google around for details. So yeah, uh, and GPU is just one example. There are many examples where you may want to have different pods be on different hardware. For example, maybe if you're doing an on-premise deployment and you have some sort of regulatory constraints about certain software can only run within certain networks, that would be a good case for node affinity. Or if only certain nodes have access to network attached storage, that would be a good use case for node affinity. It's basically just a way to select where you want pods deployed. Any questions about pods?
Uh, can these pod like deploy in a multi-cloud, or are they like localized in a like a private cloud or that way?
Uh, a pod belongs to a Kubernetes cluster. So if your Kubernetes cluster spans multiple clouds, your pods can be deployed across clouds.
Okay.
Um, I have not heard of Kubernetes clusters spanning clouds, but I don't see why it would not be possible. I definitely think it could be
Yeah.
possible. Um, but it would need to be self-managed, not cloud provider managed. And it also sounds like it'd be a giant pain in the ass, but it's definitely possible.
Okay.
Yeah. Uh, yeah. We can talk about that later if you want. Any other questions?
Notes.
Cool. Now, last thing about pods, you will almost never create a pod directly. You will use something else to create pods for you. And usually that something else is a deployment. Um, a deployment defines zero or more um, sets of pods. I say zero or more because there's other things you can define in a deployment as well. But usually they're pod focused. And these deployments create a controller, or again, zero or more controllers that manage the pods for you. And this is really where the value of Kubernetes comes in, is the deployments. There are three types of deployments you can create: replica sets, stateful sets, and daemon sets. Most of the time, you will be doing replica sets. For example, REST APIs, because the REST API is stateless, you will use a replica set. If you're doing something that is stateful, like a database or a Prometheus deployment, that should be on a stateful set. Replica set basically says, I have some number of replicas of some pod, and I don't care about their state, just make sure I have some number of these pods. Stateful set says, I have some number of pods that need to maintain their state, so once a pod is allocated to a node, it's going to stay on that node, even if you kill the pod and it gets recreated. On that note, these different controller sets have, similar to auto scaling in cloud providers, they have like a desired number of pods, and if the desired number or if the actual number of pods currently running is lower than the desired number, they will automatically deploy a pod for you. If a pod dies, they will create a new pod, all these kinds of things. And the third type of controller set is a daemon set. This is useful for things like logging collection agents and metric collection agents. Basically, a daemon set ensures that at least one replica of a pod lives on each node in the cluster. again, which is why it's useful for things like logs, because you want to collect logs from all nodes in your cluster, right? Um, and I pretty much explained all the other bullet points without looking at them. Yeah, that covers everything on there. Any questions about deployments?
Not right now.
Can they be can they be mixed? For example, I can set replica set and daemon set at once.
Yes, you can have. The sets themselves would be separate, but you can have them as part of the same deployment. Wait. I believe. Hold up. Let me check. I could be wrong about that. Show me the example YAML. Wait, really? I'm sorry, I'm wrong. One deployment maps to one set based
Okay, so I
on.
need to
Yeah.
choose.
Sorry, what were you going to say?
Okay.
Okay, cool. Yeah, basically when you so as I mentioned before, I was going to get to this when we get to the interactive part, but we'll just look at it for now. This is an example of a Kubernetes object defined as YAML. This is an example deployment. The spec defines what pods will be deployed. This is going to be a replica set, and you basically specify the template for your pods, and then basically what image they're going to run, what the pod should be named, what ports you want to expose, all that kind of stuff. Yeah, so if we look here at replica sets briefly, yeah, you can see that it basically looks the same as the previous one, showing a stateful set. Yeah, you just add this right here where you set the kind to stateful set. So yes, I apologize, I was wrong. It is one set for one deployment. Actually, wait a second. You know what? Now I'm confusing myself. Wait a second. Sorry. I almost never use stateful sets, so. Oh, wow. I'm sorry. I am super wrong. Jeez. I am so sorry, guys. Holy crap. Let's fix this. There we go. There we go. That's weird. Did that change or did I just learn this wrong? No, that's right. Right. But sorry, guys. Yeah, what? Okay, I'll check into that later. That is suggesting that deployments and replica sets are kind of the same thing, but they are separate objects in Kubernetes. I'm going to need to look into that because 99% of the time you're just going to do a deployment using a replica set. It's very stateful set. If you're doing cloud stuff, usually it's easier to just use a cloud provided stateful system like a database or Elasticsearch cluster or whatever. So I don't really use stateful set. So that's where I got a little bit confused. But I'll check into that when we get to the interactive portion and get that cleared up. I apologize. But the important part is that you know about the three types of sets. Sorry, Peter. I went down a bit of a rabbit hole. Did I answer your question?
No problem. Yes.
Okay, cool. Basically, they would be separate objects, but you can define as many as you want, or rather, as many as your cluster can support. Cool. And that's often how you'll do things. For example, let's say you are deploying a database. Let's say you're doing like everything in Kubernetes. You don't want anything outside of Kubernetes. Like say you're doing an on-premise deployment, and let's say you're doing a standard, a kind of standard restful, or sorry, not restful, a standard CRUD app, right? You might have a replica set for your web front ends, a replica set for your API backends, and then a stateful set for your database instance or instances, and then maybe a daemon set for like monitoring and alerting and all that kind of stuff. So you can mix and match as needed. Cool. So moving, any other questions before we move forward?
No.
Cool. All right. Next important thing you'll need to know about are services. The simplest way to think about services in Kubernetes is that they are more or less a DNS entry. They actually do quite a bit more than that, but the simplest explanation is that they are a DNS entry. And usually they are internal. This is, if you remember from part 1, we talked about service discovery. This is how Kubernetes does service discovery. When you create a replica set of pods, you don't necessarily know where those pods will be placed, or they might move around. So what you do is you give those pods some label to identify them, and then you create a service that uses that label to target those pods, regardless of where they go. And in this way, if you hit the corresponding DNS entry for a service, Kubernetes will figure out which pod matches that service and direct your traffic to that. Software-defined networking. Fancy. There are 4 types of services. The most common type that you will use is a cluster IP. It's basically just an internal IP address in the cluster. What you will use less frequently is a node port, where if you're familiar with host networking in normal Docker land, it's the same thing. The pod deployed to some node gets a node on the physical host as requested. And that's useful for if you need to do node specific targeting of something. What you'll see also often is load balancer, which is, it basically just requests that the cloud provider provide a load balancer. So if you're on AWS, this will create, well, if you have things configured correctly, it will create a application load balancer. If you're on GCP, it'll create a load balancer, all these kinds of things. And usually when you do this, depending on which cloud provider you're using and which load balancer controller you're using, which we'll get into later, it will automatically create other services to load balance among for you. But this part, usually you're going to have some tutorial that you're following to do this. So you don't need to get too deep into this, because when you're only going to need to do this once on a cluster usually, and you're usually going to be following some guide to do it, unless you're doing on-premise, in which case, good luck. And then lastly, as external name, I see a lot of people are kind of like, what's the point of external name? External name is actually really useful. Let's say, or first I should explain what it is. An external name is basically providing a cluster internal DNS entry to point to some service out on the internet. And a lot of people would be like, well, why don't I just give my applications the DNS for the service out on the internet? The main reason is environment management, in my mind. There are other arguments as well, but this is the strongest one for me. Let's say you have your ABC application, right? And your ABC application is using a third-party database service like MongoDB Atlas or something. And let's say you have different MongoDB clusters for each of your environments, like dev, staging, and production. Let's say you have 3 environments, and each one has a different cluster. You could, in your deployment of your ABC application in Kubernetes for each environment, just set them to each different, set the application settings for each different DNS entry for your MongoDB cluster. You could do that. That's totally reasonable. I would argue an easier way is just have your application point to mongodb.service.local, I believe is the default internal domain name, or the service local part being the internal domain. I'll need to double check that when we get to the implementation part. But you can basically use a consistent DNS name for your applications. And then on the Kubernetes side, have your alias DNS external name point to the different MongoDB node clusters.
It's some kind of like CNAME in DNS? Or?
Exactly. It's basically just a CNAME.
Okay.
Yeah. Sorry, that would have been a much simpler way to explain it. Thank you. So any questions about services?
No.
Cool. All right. Next up is ingresses. Some people get a little bit confused between services and ingresses, but they do serve very distinct purposes. Services are usually, keyword usually, internal. They're for service discovery, discovering your applications within the cluster. Wait, did I share the present? I did. Cool. Ingresses are an entry point for external traffic outside of the cluster coming in. And an ingress will point to one or more services. Okay, so you can think of services as kind of your internal networking rules and your ingress as your external, or rather, inbound traffic from external networking rules. Additionally, when you set up an ingress, you need some kind of ingress controller, something to handle that outbound traffic. And kind of as I mentioned before with the load balancer service, cloud providers will have their own ingress controller, and I'll show you the AWS one in a bit. And otherwise, the Nginx, if you're doing on-premise, the Nginx ingress controller is pretty popular. I'm not saying you absolutely must or should use that one, but if you're Googling around for on-premise ingress controllers, that's probably going to be the most popular you'll find. Other good ones that I have heard of but not used are Kong. Kong seems to have a pretty good share of things. And then, what was the other big one? I don't remember what the other big one is, but I'll add it into the presentation later for your reference. But there's a whole bunch of different.
Istio.
Which one?
Istio.
Istio. Yes, Istio. Thank you. Yeah, I was actually looking at Istio at my last company when we were trying to do an on-premise deployment. Yes, Istio is a big one, and then there's another one that's similar to Istio as well. But I'll get a list of them and toss them in the presentation for you. Oh, damn it, it's the Golang one. Traffic, I think, works as an ingress controller. Maybe, I'm not sure. I'll double check. But yeah, there's options in any case. And then when you define your ingress, you can do either host-based or path-based routing, just like any other load balancer. And you can have multiple ingress controllers and their configurations. For example, if you need internal load balancer, like, for example, if you have traffic coming into the cluster, but from a private network versus traffic coming into the cluster from a public network, you might want to use different ingress controllers or load balancers for those. And in those cases, you can use something called an ingress class to say, hey, this ingress applies to this load balancer, this ingress applies to that load balancer, to do more flexible and directed routing. So yeah, any questions about ingresses? Cool.
No.
All right. So next up is kind of the little more boring but useful stuff. Config maps are how you store configurations. And they're basically just a key value store. Usually they're organized such that the key can be a file name and the value would be the contents of that file. But you don't have to do it that way. You'll often, an also very common way is the key is some environment variable, and then the value is the value for that variable. And you can inject this data into pods using either of those methods. You can mount the keys in the config map as a file on the pod container's file system, or you can inject it as an environment variable. Both are fine. It's a matter of preference, and they're both easy to configure in the YAML. But I will emphasize, do not use config maps to store secret data. Config maps is just raw data, whereas we have another object called a secret in Kubernetes, which actually encrypts your data. And that's where you should put things like passwords and such. But beyond that, they work pretty much the same as config maps. And they can be injected into a pod in the same way as a config map, either as a file or as an environment variable. Additionally, secrets provide many different types. Most of these, I would say, are for convenience purposes. By default, it'll just be the opaque type, which is basically here's a key, here's a value. But you can also do service account tokens, Docker configurations, HTTP auth, SSH auth, all these kinds of things. And they're really just ways to make it to kind of enforce the structure of secret data for you, and just to make things a little bit clearer. You could theoretically accomplish the same thing using the opaque type, but they just make it a little bit easier for you. Yeah. So, any questions about config maps and secrets? Cool. All right, and doing great on time. Storage. Storage is the big scary part for a lot of people because it can get really messy. Storage is kind of divided into three components when it comes to Kubernetes, three different types of objects. One object is a storage class. It's basically just a way to define some category of storage. For example, if you have like high-speed storage versus low-speed storage, or different size constraints, or all these kinds of things, you would want to use different storage classes. Usually your cloud provider provides instructions on storage classes. They'll often provide a default storage class with a default size, and they'll provide instructions on how to create additional storage classes of different sizes or different IO types or whatnot for you. And that defines what kind of storage is available to you. Following that, the way that you actually get storage for your pods is you define what's called a persistent volume claim. The persistent volume is the storage itself, which is a separate type. And the volume claim is basically a request for that storage. So you will define the claim, and then Kubernetes will provision the volume itself for you. And like I said before, this will most often be used with databases and stateful sets. Yeah, if you're doing this on premise, it can be a bit of a nightmare. You basically have to define your own storage interface and hook it up to your network attached storage, or to your to the host operating system for the node that is on the cluster. There are instructions to do that, but like lots of things on premise, it's just not fun, but it's certainly possible. Any questions about storage? Cool. So that was a whole bunch of information that just kind of got dumped in your head. The reason that I did it in kind of like, here's a rapid fire list of all the just information, is because when the volume of information is that large, you're not likely to retain it on the first try. So we're going to kind of keep revisiting things throughout the rest of this class, so that, again, repetition, so you can get it in your head and figure out which parts are important, which parts are used most often. So on that note, first pass at reviewing, here's a little diagram I threw together of kind of the different types of objects and how they interact with each other. Again, this is not all the objects in Kubernetes, just the ones that we covered today, and the way they interact with each other. So you have some cloud provider, ideally, or if you're doing on-premise, you have your data center, basically. And then you have your Kubernetes cluster. Usually the entry point for outbound traffic, or I'm sorry, inbound traffic from externally is some ingress, which maps to some cloud provider load balancer. That ingress sends traffic to a service, and that service sends traffic to some pod. Additionally, to configure your pod, you define some config map and or some secret you can mix and match. And you inject those into the pod either as files in a volume mount or as environment variables. And then if you want to give your pod storage, you do that through a persistent volume claim, which allocates a persistent volume, which gets mounted into a pod. And then to actually deploy these pods, you use, which actually, you know what, I need to fix this in case my understanding of deployment earlier was wrong. But you define one of your different controller sets, a daemon set, replica set, or stateful set, to actually create and manage your pods. So does this make sense to everyone? Does anyone have questions about how these things fit together?
It's okay.
Cool. All right. So that said, let's move on from just talking about the objects to actually do some stuff. First, we'll go over kubectl. We touched on it a little bit during part 1. Basically, it's a command line utility to manage Kubernetes, and it's basically just a wrapper for the Kubernetes API. You could do pretty much the same thing using curl, but then you would hate your life. So use kubectl because it's easier. And let's actually do some stuff because you've been listening to me talk too much. If you have not installed kubectl, go ahead and do that now. I don't think I have it installed on my host machine. I think I only have it in my subsystem for Linux. So I'm going to go through this with you, I think. Oh no, I do have it. But basically, I in the presentation I have links to the different setup for both Windows, Mac, and Linux. Yeah, unfortunately, if you're on Windows, you're going to either have to install curl or chocolatey or scoop to get it. It's going to be easiest. I think installing curl on Windows is pretty easy though. Yeah, there's curl for Windows. So you can just do that if that is your preference. Super easy and straightforward. Otherwise, if you already have chocolatey set up or scoop, you can do that. I use chocolatey quite a bit. I recommend it. I did not know about scoop. I don't know which one is better. But they're basically package managers for Windows. And if you're not using one of them already, you should totally try it. So go ahead and raise your hand in Google Meet once you have kubectl set up so we can move forward. And if you have trouble getting it set up, let me know. You guys are great. Okay, cool. Let me lower all hands. Cool. All right, so that said, let's dive in. It's going to make the recording super easy. Thank you, guys. So first, we're going to configure access to our cluster. I was trying to do this without AWS specific stuff, but my time was limited. So we're going to have to do some AWS specific stuff. So if you don't use AWS normally, I apologize. I'm going to ask you to install some AWS software. If you do use AWS already, you either have this set up already or probably should get this set up, in which case, cool. So again, I have links for setting up the AWS CLI. We're going to use this to configure kubectl to access the cluster because I deployed the cluster on AWS. So go ahead and install the AWS CLI according to these instructions linked here. And then I shared links to you guys in the chat with the credentials files. And I'm going to ask you to, after you get the AWS CLI installed, use AWS configure to set up your account using the credentials in that file. And then Ankur, you'll use intro cluster 1, and then Peter, you'll use intro cluster 2. And you know what? I should probably fix up because I was doing everything in. Let me minimize this so you guys can see. There you go. I was doing everything in WSL, and I kind of want to follow along with you guys. So we're going to do AWS EKS region, AP Northeast 2, update kube config, name prep cluster. I don't have AWS installed on here. Cool. Can you guys go ahead and raise your hand once you have gone through this stuff?
Yes, I have added new context to config.
I'm sorry, say that again?
I have run this command and I have message added new context with this
Excellent.
cluster to kubeconfig.
Cool. Can you do me a favor and hold up. I don't remember what the command is. Let me check it. Can you? Yeah. I'm getting there. Chill out. Can you do me a favor and do kubectl config get contexts and tell me how many contexts it says you have?
Just one.
Cool. Okay, then you're good. All right, so I'm installing
Current
this.
with asterisk.
Sorry?
Q1 only with asterisk star. So it's default something.
Cool. Great. Excellent. Whoops. Give me that. There we go. That's what I'm looking for. All right, so let me check hands real quick. Cool. So go ahead and put your hands up once you got the stuff done. Okay, so I'm gonna. Oh, you guys are faster than me. Damn. Oh, right. I have to restart my shell. Oh. There we go. So now what you guys should be able to do is if you do kubectl get all -- all namespaces just like this, if you can see on my screen, if you run that, you should see a whole bunch of stuff come out. And if so, you know that you have things configured correctly. You'll see less than what I have here because I was using this cluster to prepare the lesson. But if you see something like this, a whole bunch of stuff, you're all set up. So if you could just raise your hand for me to let me know that this is what you see and you're all configured correctly, we can move forward.
Can you show this command?
Sure.
kubectl config all. Get all. Okay.
And I was tight on
I have
time.
comment that I should be logged in.
Oh, I'm sorry. Yes, I apologize. We skipped a step. Oh, no. Did you run the AWS configure?
Yes.
You did. Uh-oh. And you use the credentials file that I shared with you in chat?
Wait a second, because something is strange, because it was working, this config get context, and right now it's not working.
Because actually no, it had to work. Otherwise your update kube config would not have worked. Can you share your screen briefly and let me see the output?
Okay.
Yeah, it's not going to be in the recording because I have that on a separate monitor, so you're okay.
Oh, no problem.
Is there a way to turn off this damn notification? I know that I am. Ugh, whatever. All right, what do we got here?
So
You
get
must be
context
logged
is
in.
working.
Interesting. Yeah, let
Get
me.
all.
Can I
I
make
have.
this bigger? How do I make this bigger? Oh.
Uh,
Okay, here we go. That all looks right.
And it's your cluster and probably your
Ankur, do you get output when you run it? Because that'll help me know if this is a problem specific to his account or
Currently,
if you're...
I'm configuring my AWS,
Okay.
and it's asking me the default region name.
I apologize. Default region name should be... I'm typing it in chat so you can just copy paste. AP North. Oh, damn it. I forgot to set one up in India for you. I'm sorry, dude. Your stuff's going to be a little bit slow because it's going to be going quite some distance.
Should I use this AP Northeast?
Yes. Well, yes, because this AWS account is going to be gone after this class. So,
Okay.
maybe because I have another region.
yeah, I would do that. And can you show your... Actually, it looks like you have other configurations, so I don't
Now
want you
it's
to show
asking default output format.
output format. Do JSON. Although it doesn't really matter. You can just leave it blank, I guess. All right,
But it's strange because this command is working
right. Like if
and get all
oh,
is
so
not.
I had to do a whole bunch of setup in order to get this to work. So it's possible that, and that's why I want to see if Ankur's works, because if his doesn't, then maybe I set up the accounts incorrectly. But if it does, then maybe I just set up your account incorrectly. So give me a second. And yes, you guys have admin access, but I'm not too worried about it because I'm blowing it up after this class. So unless you can abuse an AWS account within the 2 hours that we're here, I'm not too worried about it. Okay, it says, wait, it says 1 has not been used yet. What about 2? We should see some usage for 2. Yeah, you just used it. Ooh, wait, STS. Is that right? Oh, maybe that's not right. Hold up. Where is it? Cluster, you're on cluster 2. No, that's the CNI.
Yes.
I don't care about the CNI. Here we go. This is what I care about. Nope, that's the load balancer controller. Yeah, here we go. Can you do me a favor and do, let's do, what? I don't know, what's list clusters? Can you do AWS EKS list clusters like this? Yeah. Okay, that's weird. Crap. That means that something is messed up. You're getting error while setting up kubeconfig. Really? Can you copy and paste the error message, Ankur? All right, so you know what? Let me make sure that there's no typo. So intro to config. Oh, really? Okay, that's fine. I think I have it. Let me open up my WSL. Ankur, I'm going to check that just in just a second. I just want to check the cube intro to config. Did I mess anything up here?
And you should add your cluster name.
Yes, you're missing the
Intro
cluster
dash
name.
cluster dash 1.
Thank you, Peter. That is correct. Huh. This looks right. Okay, here we go, Peter. Can you try running? I'm going to throw a command at you real quick. We're basically, so the way that login works with AWS and EKS is you ask AWS for a token for the Kubernetes cluster. AWS goes into Kubernetes, generates a token, and then gives it to you. So we can also do that via the AWS command line. So you can do AWS EKS get token cluster name, intro cluster 2 for you, Peter. So tell me if you get something like this output.
Yes, I've got.
Oh, what the hell? Do I have a kube config? All right. What do I have here? Oh, I just have the prep cluster here. All right, cool. So what I'm going to do is I'm going to mimic your setup, Peter, and I'm going to see if I have the same problem, because that'll tell me where the issue is. So this is Windows, and I'm just going to grab this guy. We're going to download it, and we're going to move downloads.
But I don't move this config, which I download.
Oh, that's right. Oh, I'm sorry. Yeah, my bad. Didn't need to download it. Right. Oh, in that
Because I download it,
case,
but I should move it to .cube/config.
no, you're okay. That was my mistake. You didn't actually need the config file because we got it through the AWS CLI. I
Okay.
changed the method midway through the presentation. In that case, can you do? Oh, you did cat it out. Okay. Shit, that looks right. That's not good. Yep, that looks right. Shit. All right.
But let's continue.
Okay.
Unless
How about you, Ankur?
it's working for you.
Ankur, can you do I'm gonna send a command to you. Can you do kubectl get all namespaces and tell me if you get an error or if you get good output. If you get an error, that means you two are encountering the same problem and I gotta fix some stuff. What the hell does my user have? I believe my user also has admin. Nope, I want users.
It's hung up.
It's hanging?
Yeah, I'm not getting it. You must be logged into the server,
Oh,
unauthorized.
see, the problem is your users and my user are the same. And if you guys don't have access, it kind of defeats the purpose of the interactive portion. So I want to get that fixed. There should be no function. Oh, checking something. Oh, hahaha. Typing is hard. There we go. Yeah, I wonder. Let me check what this says. Oh, this is Windows, not Linux. That's weird. That's exactly what I expected. There should be no functional difference between your users and my user. All right, let me check one last thing. I guess if it comes down to it, I can just give you. Aha! I can create new credentials on my account and share that with you. That would do it. Let me just check one more thing. Yeah, that looks right. Yeah. What the hell? All right, so let me go back to resume presenting. Here's what we're going to do, guys. I'm going to generate some new credentials for on my user account, because we know my user account works. And then you guys can just do AWS configure again and use these credentials instead. So let me create a new access key for you guys. And access key ID as this, and secret access key as this. And I don't care that these are in the recording or public, because they're going to be deleted very shortly. So if you guys could run AWS configure and use these values instead, and then try the Kubernetes or kubectl get all, it should work. I'm really troubled about why it didn't work in the first place, though. Nope, that's fine.
Yeah, now it's working.
Yeah,
Cool.
it's working.
Cool. All right, sorry about that hiccup, guys.
No problem.
Really don't know why that didn't work. Okay, whatever. We got past the problem. So, back to Kubernetes land. We're good there. So, before we get into doing stuff on the CLI, we're going to deploy some resources so that there's actually stuff to go look at and play with. So back in the presentation, if you guys have heard of the 2048 game, it's basically just kind of a number puzzle spatial game. We're going to deploy that to your Kubernetes cluster. And after we have done that, we will look at the Kubernetes objects using the kubectl CLI. And then we will look at the definitions for things so you can see how you would define things yourself. So go ahead and on slide 19, go ahead and copy and paste this and run that. Once you've run that, it's going to take a few minutes to actually deploy because it needs to deploy a load balancer. So once you've run that command, please raise your hand for me, and then we can explore things together. Looking good. And all right, cool. So let's play with stuff. So at this point, let's kind of go from the outside in. The YAML that you just ran created a number of different objects in Kubernetes. We're going to look at those objects to understand how this application got deployed, and then, to look at what objects got deployed and understand how they interact with each other. And then after that, we're going to go look at the YAML that defined those objects to see how it all worked together and how to define it ourselves if we want to do that in the future. So first, let's start from the outside in. Let's look at the ingress. Remember, the point where traffic from outside of the cluster can come in. So if you do, but before we do that, we should pick our namespace. So let's do kubectl get namespaces. When you're doing kubectl, most of the time, the syntax that follows is some verb like get or describe or edit, followed by the type of object, and then optionally like some name of the object. If you run this kubectl get some object type, it'll usually just do a list. So if you do that, we'll get a list of namespaces. Okay, and then that YAML that you guys ran went ahead and deployed a namespace named game-2048. You know what? I actually never learned how to do this. kubectl set default namespace. How do you do that? kubectl set config, specify the name. That's not very helpful. Okay, so just for purposes of making things faster, let's go ahead and so that you don't have to type as much. Crap. Basically do kubectl config, set context current, because we don't want to change the context, but set the namespace to game-2048, and that'll just save us a whole bunch of typing. And then you should see context modified. So now, has everyone got that?
Yes.
Cool. So now if you do kubectl get ingress or ingresses, it recognizes both the singular form and plural form. I think it also supports the shortened forms like ing maybe. Yes, it does. And there's a whole bunch of shortenings for things. So you will see that that YAML we ran created this ingress object, and it actually allocated a web address. We're not going to visit that quite yet because it might not be up and running yet. It takes a few minutes.
It's working.
Oh, it's working. Okay, cool. That works. Well, then might as well just demonstrate here too. So you'll see we have, did it keep my history? Oh, it kept my history. Look at that. It's a good little app. But basically this is the application that you deployed to Kubernetes. So congratulations on running your first application. And 2048, you just play it with the arrows. You can move stuff around, get points, all this kind of good stuff. Oh crap, I made a mistake. Okay, but you're not here to watch me play games. So the ingress is how traffic coming to this web address gets into our cluster and accesses our applications. We're going to get to how it knows this address and how the internet routes to this address. We're going to get to that later. I don't want to worry about that for now. Now, if you do, so doing get will just give you the kind of basic information. If you do describe, you can get more detailed information. So if we do kubectl describe ingress, and then we do the name of the ingress object, which in this case is ingress 2048, you can see more detailed information about the ingress. Is everyone able to run that and see their output? And I apologize that Windows doesn't have pretty colors on its command line. If you know of an alternative
Okay, I
command
have.
prompt, please tell me. What's up?
It's running.
Cool. So you can see, you'll see rules. I mentioned earlier that ingresses can have host-based routing or path-based routing, or both. And in this case, this accepts traffic from any host to any path, and it directs it to this service. So now if you do kubectl get services, or service, or SVC, it'll show you a list of services, and you'll see this service 2048. The ingress routes the traffic to here. The ingress is the external, the service is the internal. And you'll see that the external port 80 gets mapped to the container port 30619 kind of thing. And then we can do kubectl describe service. And then we can see more detailed info about the service. I mentioned earlier that services direct traffic to pods based on some selector, and that selector is based on some label. So what we can do now is if you copy this selector info right here, and you do kubectl get pods, and then you can use the -l flag to filter by selector. And if we paste this label definition right here, these are the pods that the service will direct the traffic to. Because Kubernetes will see an internal DNS entry for service when it receives traffic to that address. It will look up the selector, look up these pods, get the individual pod IP addresses, and route the traffic to there. Does
So
that
you
make
have
sense?
5 different Dockers which run this application, right?
Yes, it created 5 different pods, or 5 replicas of the same pod. Yeah.
So it doesn't need anything like Nginx for service discovery.
No, it has service discovery built in. That is what the service object is.
Okay.
Yes, good question. Other questions? Cool. Now you'll notice each of these pods has some name, some random generator thing, and then another random generator thing. This name is the name of the deployment. Remember earlier, we have the different set controllers that create and manage pods. Now, I know that this, I happen to know that this deployment is a replica set. So, and this deployment is configured to maintain 5 pods. So what I'm going to do is I'm going to simulate a pod crashing. We're going to take this X4JWQ, and you can take the bottom pod on your output, or whichever one, it doesn't matter, just pick one as long as you know which one it is. I'm going to copy this, and I'm going to do kubectl delete pod. And I'm going to destroy one of our application containers. So that container's gone, killed it. But you'll notice how the command is not finished running, it's still hanging. And now it finished. Because Kubernetes knows that this pod is still part of a replica set, what it's going to do is, if I list this again, the reason it paused was because it didn't want to output until it recreated a new pod to replace the pod I deleted. So now you see that this new pod came up 18 seconds ago to replace the old pod that I deleted, because the replica set is configured to deploy 5 replicas.
Okay. So if there was a database on that pod, for example,
Yep.
what would happen to the consistency and all these things?
If you were using a replica set, you would have a bad time. If you're using a stateful set, Kubernetes would redeploy a new pod to the same node and maintain any state information it had, like persistent volume connections or persistent volume bindings is the correct term, and things like that, so that the database tries to get as close to the same state as it was before it crashed.
Okay.
Other questions?
So there are like some databases like federated databases that try to like select a leader and they come to a conclusion after that. So if the pod was a like a part of a federated database, so after the new pod comes up, they will again try to do that federation and come to the normal state.
Yes.
Okay.
Yeah. So basically, what would happen is, let's say you have 3 nodes of that cluster, and one node disappears.
Yeah.
Sorry, I should be going this way in case we have any British people seeing. Sorry, Josie, when you look at this recording later. Or I should do this. There we go. So let's say this node is the leader, and it
Yeah.
ends up dying. These 2 will renegotiate who the new leader will be, right?
Yeah.
And then what'll happen is this guy will come up with the same state, but because its timestamp is in the past, whatever the newly elected one was will maintain the state, and everything should be cool.
Okay.
Yeah. At least that's going to be specific to the implementation of that application's clustering logic.
Okay.
But to my knowledge, most clustering works in that manner. So because the old leader has old data, the other ones should pick it out, because the old
Yeah.
leader will maintain its old data from the previous state.
Yeah.
Cool. Other questions? Cool. All right, so let's check out this deployment real quick. If we do kubectl get deployments, you'll see that we have this deployment 2048. You'll see we have 5 of 5, and all 5 are up to date and available. And the age of the deployment is 4 hours, because that's how long ago I set up this deployment. So, but that's not terribly interesting. What we can do, however, is describe that deployment. So let's do kubectl describe deployment, and then paste deployment-2048, or type it if you like that. And now we get the interesting stuff of, we can see the namespace, we can see the selector that gets added to the, or that basically makes those pods part of the deployment. You can see the auto scaling kind of stuff where, desired, updated, available, all these kinds of things. The nice thing is that most of the time when you define a replica set, the default is rolling update. So if I were to deploy a new version of this application, let's say a new image tag for this pod image, then it will try to maintain uptime by taking down one node, getting a new node up in its place before taking down the next node. And in this way, it maintains uptime. So for example, my company, we do deploys all the time because there's no downtime. Because Kubernetes does a rolling update preventing any downtime for the application. And we're only running one node. What it does is it spins up the new node, make sure that's working, and then it tears down the pod. Spins up the new pod, make sure it's passing checks, and then kills the old pod.
What if a node goes down?
In that case, you're going to have a bad time. Oh, if a node goes down. So Kubernetes generally will try to distribute pods across nodes. If in this case, our clusters only have one node, but which is super dangerous. But in the case that you have multiple nodes, it will try to distribute the pods across multiple nodes for redundancy. You might, and if it is able to do that, you might experience a slight blip while the Kubernetes service updates to remove that pod from its pool. But it's usually really fast. Like you might encounter a blip depending on your traffic throughput. But usually it will see that the desired numbers of pods is greater than the actual number of pods, and it will try to reallocate them to other nodes. If it is unable to allocate them to other nodes, it'll basically just keep polling the cluster to see if there's any node capacity to deploy to. And ideally, your alerting system, if you have one set up, will alert you that, hey, there are N deployments that aren't at their desired pod deployment. So does that answer your question?
Yeah.
Cool. Other questions before we continue? Cool. All right. Basically, here the pod template defines how the pod will get deployed. You can see that we can set the host port and container port. We can set the image and the tag. In this case, there is no tag, so it's just using latest. You can set environment variables, mounts, volumes, all that kind of stuff. Standard Docker stuff that you guys are familiar with, I'm sure. Additionally, this events property is usually really useful. It will tell you of things like try to allocate pod but was not at capacity, all that kind of stuff, or but no available capacity or whatnot. Yep. Now, because this deployment is a replica set, you'll see that it creates a new replica set. Yeah, so deployment and replica set are not the same thing. You can do kubectl get replica sets, or I think rs is the shorthand for it. So now if I do kubectl describe rs, you can see that it successfully created some pod. Oh, hey, this was when we deleted that pod. It successfully recreated the new pod to get back up to the desired number of pods. And you can see other stuff like the maximum number of replicas is 7, the desired number is 5, so on and so forth. Any questions about replica sets deployments? Or are you guys feeling good?
No. Good.
Cool. All right, and is there anything else? I don't know if let's see. Okay. I don't think we have a config map for this. Yeah, there are no config maps, and there's no volumes. Yeah, so that's pretty much it. kubectl get all. Let's just do that for kicks. We covered service, we covered deployment, we covered replica set, and we covered pod. Cool. All right. So any questions about how these different Kubernetes objects interact with each other, or do you guys understand how they work together?
Kind of works. Decent understanding. I'll rewatch again.
Cool. It is a
Quite
lot
okay.
of information. What's up?
Quite okay.
Cool. All right.
Understanding.
So now let's real quick just to let me go ahead and pull up the diagram I had here just to kind of again repetition so that the stuff sticks better. You're not going to 100% remember everything that we go over today, but we want to try to get as much as we can into those wonderful brains of yours. Let's do something like this. I swear I know how to manage monitor real estate. Oh, maybe I don't. Yeah, okay. So again, we have our ingress is not listed here, but we have the ingress that you guys saw at the beginning that accepts the inbound traffic from the outside. That gets directed to this service. The ingress ended up defining a node port for this service because that's how it needs to work with the load balancer. Different load balancers will do things in different ways, but we'll talk about that in a bit. That service is then pointing to these pods using that selector that I mentioned earlier to identify the pod. These pods are managed by a replica set, which is part of a deployment, and the replica set maintains the 5 pods. Okay, so just kind of, again, repetition to remind how all this stuff works together. Cool. We did this already. We did this. And you guys were able to see this replica set, or rather this game that I'm terrible at, as a kind of demonstration of everything working together. So what was so next up, let's so you guys have seen the stuff in Kubernetes, but let's open up this link here and take a look at the YAML. You know what, let me put this into something that doesn't suck for reading YAML. Oh, that's so much better. Okay. So, and do we have collapsing? Not the kind of collapsing I was hoping for. Okay. So again, Kubernetes objects are often defined via YAML. And this was the YAML that deployed all those objects that we just took a look at. So we started with the namespace. You can see that all of the Kubernetes YAML starts with this API version. And that's the version of the Kubernetes API. So usually that's going to be a constant. That's not going to change so much. Following that, you're specifying the kind of object that you're deploying, whether it's a namespace or pod or a service or whatever. Okay. Following that, you have metadata. So stuff like the name, stuff like if you're going to put it in a separate namespace, if you're going to add a label or whatnot. So that's our namespace definition. Next up, following the same path that we did before, let's jump down to ingress. API version, you can see this is actually outdated. I think they changed it. But API version is which part of the Kubernetes API that this request is going to go to. Because remember, kubectl is just a wrapper for the Kubernetes API. We're deploying an ingress resource. We're deploying it to that game 2048 namespace that we created in the previous object. And we're defining a name for the ingress. Additionally, we have some annotations. Remember, annotations are what the system reads. These are less for humans reading. In this case, this ingress sets up annotations that AWS uses to read about our ingress and figure out how to deploy our load balancer. So you'll notice they have this Kubernetes io.ingress class. I mentioned earlier, ingress classes you can use to separate ingresses being allocated to different load balancers, and that's what's happening here. Specifically for AWS, you can do an ALB for an application load balancer, or I don't know if it's ELB or NLB for a network load balancer, but that's an option as well. And then you can define whether it's internet facing and whether it's a target type or instance type. If you're not familiar with that, those are AWS specific things. And just to kind of demonstrate, we pop on down to load balancers. Oh, the hunger is real. Why the hell do I? Oh, right. Of course there are 3 because we have 3 clusters. So these are load balancers in AWS, and you will notice that there are 3 of them because there are 3 of us, and each of us is running our own cluster. So if you were to expand these, oh, it doesn't have the cluster name in them. I thought it did. That's unfortunate. But basically, if you take a look at these, there's got to be the cluster name somewhere in here. Oh, it doesn't have the cluster name. That makes auditing a giant pain. I thought it did. Guess I was wrong. All right. But basically, due to some, so I mentioned earlier when we were talking about ingresses that there are different ingress controllers. AWS has their own ingress controller, and that ingress controller acts as the bridge between Kubernetes and AWS. And what it does is looks at Kubernetes objects. For example, this, nope, 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 nope. This ingress object, and it reads these annotations, and then after reading those annotations, talks to the AWS API to request load balancers. And then you'll see that these load balancers create the load balancer rules to direct traffic to our Kubernetes cluster. So that's how all the stuff works together on the AWS side in a very light way, because I'm not teaching AWS today. So these annotations are used by AWS because remember, annotations are for machines, labels are for humans, mostly. And then you'll see these rules like we showed before back in the command line. Any path leads to our 2848 service. And then if we look at the service definition, here's our 2848 service. Again, we're doing port 80 like we showed before. They're doing node port due to the way that the AWS load balancer works. They need to use load port instead of cluster port or cluster IP. And then the selector shows which pods the service will route traffic to, just like we saw in the command line. Following that, or lastly, we have our deployment, which defines our spec for our pods. It defines basically how the deployment will recognize what pods belong to it, and then how many pods we want. In this case, we want 5. And then following that, you have the template for your pod. Basically, what is your pod going to look like? And we set the label so that the deployment recognizes, hey, these pods belong to me. And then you set the spec for the containers. They're gonna, and you'll notice here that under containers, it's a list. I mentioned earlier that you should have 1 container per pod, but you can have multiple containers per pods, but you should generally avoid that. And then you specify the image, pull policy, your name, and then any ports that you want to map. So this is pretty much how the YAML works. It's almost a one-to-one mapping with what we saw in the command line. The only difference is that a deployment will automatically create a replica set, unless told otherwise. Any questions?
I just have one question.
Yeah.
I saw an example in which about eBay, and they were like deploying a Kubernetes cluster using a Kubernetes cluster. Like they were using a Kubernetes cluster to control a Kubernetes cluster. So um, if you were like to deploy bare metal, uh, bare metal servers, uh, can you control them with Kubernetes clusters? Like how would that happen?
So there's no value to having a cluster within a cluster. But what they're likely doing is they have some kind of, without seeing the article, I can't say for sure. I'm just kind of gonna guess at it.
Yeah.
But it sounds like what they're probably doing is they have some Kubernetes cluster that's kind of a deployment master. Like it might be their CI/CD system, or it might be a dedicated deployment system. I don't know.
Yeah.
And then they probably created some Docker container that has all of their scripts for provisioning Kubernetes on some hardware. And then that Docker container probably, or that script probably just goes to that hardware and installs Kubernetes on it, is my
Yeah.
guess. On that note, there is something that we have not covered today, which is relevant to that example you showed. Kubernetes has the concept of jobs, because it sounds like they probably created a Kubernetes job. And then a job is, it's kind of another deployment, kind of another set controller, except that whereas these other set controllers, the pods are long lived, you want to keep the job alive, or you want to keep the pod alive. With a job, what it will do is run the Docker image, and it expects that Docker, or run a Docker container, and it expects that Docker container to exit with a 0 status, a successful status. And that's probably how they're doing their provisioning stuff, because there's no point in having their provisioner keep running.
Yeah.
So I'm guessing they're using jobs to go connect to that new infrastructure and set up a Kubernetes deployment using probably kubeadm or something.
Yeah.
So does that I'm not 100% sure that that's the answer, but that's just how I would
Yeah.
guess they
That's
do
the
it.
way it can happen. Like, I understand.
Yeah, cool. So that answers your question.
Yeah.
Cool. Other questions? Cool. In that case, let's see. There were two possibilities at this point. What were they? And how are we doing on time? Oh, we're doing great on time. No, we did that already. Yeah, we're probably okay. A note about the Kubernetes YAML. You're probably not going to be expected by anyone to memorize all of the YAML for all the different types of Kubernetes objects. Most often what you're going to do is you're going to find some example like this, and then you're just going to change the values, and then you're probably going to look up stuff. Like Kubernetes is so damn huge, like these docs, there's a lot of them. And just like if you're like programming Java or some stuff, you're not going to memorize the entire damn Java SDK. That's just absurd. But you'll know what kinds of things are available, and then you'll know how to find those things in the reference and then build them. Same with Kubernetes. Over time, you'll get to the point where you'll have memorized the important stuff, and you'll be able to do that without any sort of looking up. But at the beginning, it's totally fine to be looking all this stuff up. Hell, I've been doing Kubernetes stuff for about a year and a half now, and you still see me looking up stuff and even getting some stuff wrong. So don't. I mean, this probably isn't applicable to you two here specifically, because you both seem like you have a pretty reasonable amount of experience in the industry. So you're probably familiar with this kind of stuff. But for other viewers who may be watching this later, who are new to this and are like, "Oh my God, how am I going to remember all this stuff?" Don't stress out too much over it. It'll come with time. So that out of the way, I want to move into the bonus material, because I don't think going through and defining a YAML file ourselves is going to be a valuable use of your or my time, because again, you're likely to just find some existing YAML, copy it, change the values, look up a reference to add the things that are missing. For example, let's say you need storage and there's no storage here, you'll want to go look up how to do that, although you would not want to do that on a replica set, you would want to do that on a stateful set. But yeah, I'm not going to waste all of our time writing YAML from scratch, because why? However, I do want to get into Helm, which is a way to do things in a much easier way. But before that, I want to field questions about anything we've covered today. Do you guys have any questions about what we've covered today? Is anything unclear? Do you have usage questions before we move into kind of fun stuff?
No.
Well, that was easy.
We can continue.
Cool. All right. So let's pop into Helm. And you guys don't have to follow along with this. I recommend you do because Helm is super nifty and I really like it. Whoa, why did it? I just wanted to click the X. There we go. Helm is a way. So you have all these YAML files, right? Or rather, in this case, we have many objects in one YAML file. But let's say you're deploying a big giant application, and you need storage, you need ingresses, you need maybe you need a dedicated load balancer controller for some reason. Um, Maybe you need stateful sets and replica sets, and you have all these different parts and pieces. And you don't want to have just one big giant 2,000 line long YAML file. Like, no one wants to manage that. So, it makes sense. You split it up into multiple YAML files, but then if you change a configuration in one file, you have to go over to another configuration and change it to match there, and you have to go back and forth between all these different YAML files to make sure everything matches up properly, because you can't have your ingress pointing to the wrong service name, otherwise you're going to have a bad time. So how do you manage that? That's where things like Helm come in, because Helm is basically a package manager for Kubernetes, where you can define YAML templates, and then you can define default values for those templates and even configurable values for those templates. And in this way, you can greatly reduce the amount of time you need to code things. Additionally, if you're deploying, for example, that 2048 game, right? That one was okay to run as just one YAML file because it's tiny, right? It's a tiny little app. But for things that are more complex, it's actually a great use case for Helm, because you could do fancy things like say, oh, I want to use this ingress controller instead of that ingress, or I'm sorry, not controller, this ingress class instead of that ingress class, or I want to allocate this storage instead of that storage, or whatever. And Helm lets you do those kinds of things. So the way that Helm does this packaging, sorry, and the reason I brought up the 2048 game is rather than download some YAML file, using Helm, you can just say, hey, there's this package called 2048 game. I want you to go deploy that to my cluster. And then Helm will just do that for you. Much easier, much more easily than defining all the YAML yourself for applications that already exist. And I'm gonna show an example of this in a minute. But before that, these packages in Helm, we call them charts. If you remember from part 1, Kubernetes is kind of Greek for a helmsman, like basically someone navigating a boat.
Yeah.
So, huh?
Yeah.
Yeah, cool. And in navigation, when you're trying to like navigate on a boat, you have a star chart to kind of help you find your way. So that's why they call it a chart. Yeah, metaphors everywhere. But a chart is basically just a collection of YAML in a tar gzip file. That's all a Helm chart is. So it's a templating engine and a tar gzip transfer tool. So what it does is you define your objects in YAML, but using Helm's templating, and then using the Helm CLI, you package them into a tar gzip. If you're defining a chart yourself, you don't have to define a chart yourself. You can also just pull one off the internet, which I'll show you in a minute. And then you can upload that chart to some chart repository if you're doing it internally, like Nexus or something. And then you can deploy it to Kubernetes. On the other hand, if you're using an existing chart, you can go find some chart online. For example, a Prometheus chart, because I know that you mentioned Prometheus earlier, Ankur. So we can look up, hold up, I want Prometheus Helm. and I can go find this Helm chart. And oh hey, instead of having to define a whole bunch of YAML, instead of having to define a whole bunch of YAML myself to deploy Prometheus, someone's already written a bunch of this YAML in the form of a Helm chart, and I can just deploy that. And I'm not necessarily stuck to how they configured it. It allows me to configure things in a custom manner. So let's go ahead and try this, just to kind of show you how Helm works. Let's deploy Prometheus to your cluster. Did I not include directions on how to install Helm? Oh, wow, I'm a scrub. Sorry about that, guys. Oh, not IO, it's SH. Ugh, all these damn programmer domains. Sorry about that. Where is it? Introduction, installing Helm. I'm just gonna toss this into chat real quick. And let me go ahead and first install Helm. Next, add Prometheus. Okay. So guys, go ahead and install Helm real quick. If you want to follow along, you don't have to follow along on this part if you don't want to. Do I have Helm installed already on here? Let's find out. I do not. So I'm going to be following along with you. I'm going to download the Windows AMD 64. Looking good. Okay, I have a software folder somewhere on my computer that I've already added to my path. Where is it? Software, software, software. Why are these not ordered in software? Eh? Oh, I'm in my projects folder, that's why. Oh, that's not cool. Well, we're gonna do it differently. I'm gonna do this kind of the hacky way. Ideally, you wanna copy this Helm file to, I'm sorry, what? Oh, ha, Windows. Nope. Let me go over here too, because I don't know what's in my downloads folder, and there might be some personal stuff in there. There's a whole bunch of junk in here. Okay, so I'm going to unzip the Helm binary. You're freaking kidding me. Okay, let me do this in my downloads folder. Okay, so we're gonna unzip this guy. I just want to extract here, please. Extract all. Yes. Cool. That's actually really annoying. And I'm going to move this helm.exe to my downloads folder, and we're going to have a good old time. Ideally, for more permanent usage, you would want to move it to a proper place, but whatever. Helm-help. There we go. So now what we can do, please raise your hands if you have Helm installed. Yeah, brew install Helm if you're on Mac. Excellent. Thank you, gentlemen. And whoop. Okay. And what we're going to do is Helm used to have one central repository, but then the Helm guys were like, there's a lot of charts and this is getting expensive, so let's not do it this way. And now Helm chart repositories are decentralized. So the Prometheus community has set up their own Helm repository. Usually, if you're setting up a new type of Helm chart, you need to add a new repository. So what we're going to do is, and I have the command here in the presentation. You're going to go ahead and copy this command to add the Helm repository for Prometheus. And there we go. It's been added to our repositories. Following that, you can do a Helm search repo for Prometheus. And this will show us all of the different charts that the Prometheus folks make available to us. Now, specifically what we're going to do is, I don't know, should we do it that way? I don't know, but we'll try it. We're going to basically copy this guy. Oh, first off, we should probably create a namespace for Prometheus. So let's do kubectl, create namespace Prometheus. Hopefully it works better for you than it is for me. Maybe this is an old shell.
It's working for me.
Cool. I must just be in a weird... what the hell? Helm sir or Helm. I forgot what I just asked you to do. Helm search repo Prometheus.
The kubectl
Yes, thank
create
you.
namespace.
Yeah, thank you. I'm doing too much crap. I already have this namespace, so it's gonna complain at me. But whoa, we created our namespace. So then now what we can do is if you searched for Prometheus, we're just going to install the base Prometheus. So you can just copy this. And now we can do Helm install. And then Helm has the concept of when you deploy a Helm chart to your Kubernetes cluster, they call it a release. So you want to give the release a name. So I'm going to call the name just Prometheus. And then you paste the chart name. You also want to do a -n Prometheus to make sure it gets deployed to our Prometheus namespace. The -n is how you specify the Prometheus namespace. Okay. So now it's gonna complain when I run this because I already installed Prometheus earlier, or maybe I uninstalled it. Let's find out. I guess I uninstalled it. Yeah. So now what just happened was Helm went to that Prometheus chart repository, downloaded the tar gzip, unzipped it, took out all the YAML, did a whole bunch of templating, and then took those rendered YAML templates and sent them to Kubernetes to deploy the objects. So now, here we go. So now what we can do, another thing that's nice about Helm is you can set up some documentation so that after someone deploys your Helm chart, you get this nice set of notes that explain what you can do next, because Helm and Prometheus are both awesome like that. So now what you can do is, of course, I think this is not going to be friendly on Windows. So I'm actually going to pop over to Linux to do this real quick. I apologize if you're on Windows, because the Windows CLI sucks and PowerShell is weak sauce. Actually, no, PowerShell is not weak. It's just not fun to use, to me at least. So what we're going to do is, so Prometheus is installed. It's up and running. So if we do kubectl get pods and we say namespace Prometheus, we should see here's a whole bunch of Prometheus stuff that's running. Okay. Now we didn't configure Prometheus to set up an ingress. We could set up. Actually, you know what? Let's take. So, sorry, I'm going too fast because I enjoy this stuff and I get excited. We have all these different pods. Prometheus deploys a whole bunch of stuff. So if we do kubectl get all in the Kubernetes in the Prometheus namespace, you'll see that Helm chart deployed a whole bunch of stuff, which is great because that's a whole lot less work that we did not have to do because we're lazy and laziness is good in certain contexts. So, now you might be wondering, I don't know how this Prometheus cluster is set up. I don't know what I just deployed. What the hell is happening? And that's totally valid. Usually, when you have a Helm chart, they all have a README. So what we're going to do here is at this the GitHub for this Prometheus Helm chart, I'm going to pop in their charts directory. I'm going to pop in this, where is it? Prometheus, which is the chart that we just deployed. And they have a README here. Oh, this is actually a crap README. Normally, a good Helm chart README, I'm a little disappointed actually here, has a table of all the different configurations that you can mess with. So what you can do is, using the ingress as an example, now we're not going to do this because we only have so much time and I don't want to mess with this. But basically, you can define a separate YAML file. So this would be a values.yaml file. And then you can, this is actually a bad example. Here we go. You can define a separate YAMLs file. And then when you do your Helm install, like we just did, you can specify this F flag to set certain values. And this is a way that you can customize the deployment of a Helm chart. I keep mentioning that Helm is a templating engine. Inside the Helm chart, there are placeholders that you can use these values to substitute into the placeholders. So in this way, if we look down at the ingress one, there's all sorts of logic. This is like the hostname rule for the ingress. This is the TLS configuration for the ingress. We could do this to modify the Prometheus deployment. Now we're not going to do that right now, but that's a possibility. But for now, I just want to kind of demonstrate what we deployed. If I can figure out how to computer. And what I'm going to do is I already have Linux configured to run on this cluster, so we're going to basically just follow their instructions, except Windows command prompt sucks. Why is it slow? Hold up. Let me make sure it actually got the value. Yeah, cool. And we can set up a port forward to that pod. And now if I go to my browser, localhost 9090, there we go. Here's Prometheus. Like a boss. Now we could have set up an ingress so that we didn't need to port forward. But honestly, I just ran out of time to prepare. But yeah, here's a Prometheus deployment. And I believe, did it deploy a stateful set? Because it should have. Deployed a daemon set. Did not deploy a stateful set. Interesting. But in this way, you can kind of see, because the storage is stateful, but the pod itself is not stateful. That makes sense. Yeah, so this is basically how you can use Helm to deploy applications much, much more easily. And I apologize I didn't get to show a good example of the values file. But if you look at the Prometheus docs, you can try an example of that. So any questions about Helm?
So this Helm is only running locally. So it's download some configuration, put some value, and deploy it to Kubernetes, right?
Exactly right.
So if you run something from Helm on your station, I can't check specific value or redeploy the same. So we
You know
should.
what? Good question, and I was slightly wrong. I apologize. What Helm does, so the reason I was so eager to say that it was all local is because Helm actually used to have a component that needed to be deployed to Kubernetes, and they removed it, and it was a huge improvement for Helm. But it does still store some data in the cluster. So if you do a Helm ls, and let's just say I do all namespaces, Helm will list out all of the releases that it has made to your cluster. So you'll notice the load balancer controller here. Yeah, and I believe, I think this information is just stored in a config map. Let me actually check that. No, it looks like I'm wrong.
Because I also deploy some Helm, this Prometheus, but with on different namespace, and I see that you don't see it.
We're on different clusters. But
Okay.
let me. You're on.
Intro 2.
Yeah, give me a second. Config. Get contexts. What? Oh, Windows. Hold up, because I do have access to your cluster. I just need to. Let me kill this real quick. kubectl config get contexts. Yeah, there we go. And then I'm going to pop over to your context. Do I have Helm installed on this already? I do. Okay, crap. I needed. Damn it. Intro cluster 2, I believe, is the one you're on. So I'm going to do kubectl config. Whoop, kubectl config use context. That one. Kubectl get pod, or no, kubectl, nope, helm ls, all namespaces, and I can see your deployment.
Okay.
Yeah. I don't know where Helm stores that data in Kubernetes. I do know it stores it somewhere. I just don't know where.
Okay, but at least it stored.
Say what now?
At least it stored on Kubernetes. It's
Yeah.
not so local.
Yeah. Exactly.
I just have a general question.
Yeah.
So, uh, in production or in like enterprise, how do you keep track of like which version of Helm you deployed with, or which version of Prometheus you were using at the
Mm.
time?
So the
So,
Helm version usually does not matter so much. But in Kubernetes, when you deploy with Helm, it tracks the app version. So if we actually crack open this Helm chart real quick, I'm just going to show you under the hood for a moment. In the Helm chart, they specify the version of the application. And that shows up in the, whoops, let me go back to Linux. That shows up in the Helm CLI.
and also the logging. What if some node goes down, and how do you view the logs, and how
Ah,
do you store those logs?
good question, and I apologize for not tracking or covering this. So with crap, actually, let me do this in Windows because I didn't change the default namespace. So kubectl get pods. In addition to this get describe stuff that I've been showing you, kubectl has a logs command, which actually logs only come from pods. So you don't need to specify the object type. So you can do kubectl logs and then this pod. Now this pod doesn't have any logs, but it would basically show you the standard out that container prints, or the containers in that pod print. In the case of a node, that's kind of up to you, because Kubernetes is not so much managing the nodes themselves as much as it is managing the software on the nodes. So if you want to collect logs from the node itself, you probably want to deploy something like FluentBit or FileBeat or some kind of log collection system, or the AWS CloudWatch agent if you're on AWS, or I believe Google automatically collects stuff. But there's various ways to collect logs from the physical host. So
Uh, is it logical to like, for example, if you have federated databases, to keep them in the same machine rather than having them spread across API calls?
you definitely want to spread them out for high availability. Um, the communication between the database nodes isn't going to matter whether they're on the same node or not, except for maybe latency purposes. But if they're in the same data center, the latency, or in the same region, the latency should be negligible, unless there's something funky with your network. And yeah, mostly
Also,
redundancy.
there's just one thing. I heard of this concept of streaming between streaming. Usually, softwares like Apache Pulsar, they do streaming. What is streaming? I didn't understand
Okay.
in the
I'm only
context
gonna
of cloud. Yeah.
Yeah, I'm only gonna cover it super briefly because it's a bit out of scope. But um, HTTP is kind of like the standard way of communication these days because everything happens over the web. And HTTP is transaction based. It's request response. Um, Now, there's other ways to do stuff over HTTP, like server send messages or something like that, and WebSockets and that kind of stuff. But streaming is basically when you have continuous throughput from one side to another in a non-transactional way, like not a request response thing. Now, Kubernetes does support streaming. Um, for example, your services you can define as TCP or UDP. You'll notice here that these service definitions have some TCP port. It doesn't have to be HTTP traffic on the TCP port. It can be some other thing, or it could be UDP. So you could be sending WebRTC traffic or whatever the hell traffic you want. It doesn't matter. Does that answer your question?
Yeah.
Cool. Other questions? Cool.
There are questions, but they will go out of scope.
That's all right. So feel free to ask stuff on Discord. On that note, um, uh, let's wrap things up. Sorry, we're 5 minutes over time, so I'll be quick. We covered what we can use Kubernetes to do. We covered various different objects in Kubernetes, not all of them, but we did get the important ones. We went over kubectl and experimented with how to use it, along with some of the YAML that's used to define various Kubernetes objects. And we did a little bonus on what is Helm and how we can use it to do packages and not write as much damn YAML. I am going to add more additional resources here. This Kubernetes concepts is basically the big giant, one of the big giant references for Kubernetes, and I strongly recommend not reading the whole thing, but bookmarking it for when you do need to find a reference. And I'll add some more resources in here. I was kind of time constrained for this one because setting up the clusters took me a long time. And I will post a link to the video in the presentation once I get that done. And I'm planning on having today's video and last week's video up today. I apologize I didn't get it up sooner, but I realized that last time I recorded the video, I forgot to hit stop on the recording for 7 hours. So that's gonna, yeah, that's gonna be fun. um, but with that, just to kind of tie off that you had more questions, but we're out of scope, you can always email me at this email address, or you'll get a faster answer if you join our Discord, which is linked here, and you can just mention me there. You can also direct message me, but I strongly recommend asking in the general channel, because then if other people have similar questions, we can help more people with your question. If you want to donate to us, we would appreciate that. This is the Korean bank that we have our account at, and it is not yet tax deductible, but it hopefully will be soon if we pass review. But I recently learned that the criteria for review are different than I understood, so chances are we will not pass review and we will not be tax deductible for a little while longer, but we're working on it. But we are more likely to pass review if we get donations. So if you have the ability to donate like $1 or like shit, it doesn't even have to be a dollar, 1 cent or whatever reasonable, whatever number is reasonable in whatever currency you're sending in, like please, because we need money coming in from multiple donors. Size does not matter. In order for us to pass review so that we can give tax deductible donations. So yes, and if you have more questions about that, you can always message me. But in any case, thank you for. There's no PayPal. There's no PayPal yet. We actually talked about that today at our leadership meeting, and I'm going to be setting that up hopefully this week. And yes, I know that's a pain point, especially because recently we've had a lot of people from not Korea, and I am going to fix that. So thank you for mentioning it, and I will message you directly once we have that up. So yes, thank you for mentioning it. But yeah, that's it. Other than that, thank you for your time, friends. And I will see you on Discord and in the future at future events. Thank you guys. Have a
Thank you
nice
very
day.
much, Ryan. Bye.
Bye. How do I computer?